Hi folks, this is the fifth and final video for Unit 7, an introduction into bonding. At the end of video 4, I had asked you to try question number 2 in your notes before watching this video. And now I will show you the answers to question number 2, where we will be determining the change in electronegativity and the predominant bonding mode for each of the following pairs of atoms. Please note that the values of electronegativity that I'm showing you here might not exactly match those that are shown on your formula sheet because they were obtained from different sources. In part A, our delta chi is going to equal 1.4. The electronegativity of oxygen is about 3.5, and that for hydrogen is about 2.1. And when you've got a delta chi of 1.4, you are looking at a polar covalent bond. In part B, the delta chi is going to be 2.2. The electronegativity of potassium is about 0.8, and that for chlorine is about 3.0. So this results in an ionic bond. In part C, the delta chi between carbon and hydrogen is about 0.4. The electronegativity for carbon is 2.5, and that for hydrogen is 2.1. This results in a nonpolar covalent bond. And finally, in part D, the delta chi between two carbon atoms is 0. Since the electronegativity for each carbon atom is 2.5, this also results in a nonpolar bond. The final section of Unit 7, we are going to look at how the type of bonding can affect the physical properties of compounds, such as boiling points and melting points. And we're going to look at three different examples: calcium bromide, silicon tetrabromide, and bromium chloride. For calcium bromide, its delta chi is about 1.8, and this is an ionic bond. For silicon tetrabromide, we are looking at a delta chi of about 1.0, so this will have a polar covalent bond. Finally, for bromium chloride, its delta chi is about 0.2, so this will be a nonpolar covalent bond. When we look at these three examples, we can begin to expect, or we can begin to predict, the types of physical properties that each of these compounds will have. In the case of calcium bromide, we would predict this to be an ionic solid at room temperature, or a salt. Typically, ionic bonds are very strong, and the melting points of these salts are very high, so they would be solids at room temperatures. Since silicon tetrabromide has a polar covalent bond, we would expect this to be a liquid at room temperature with a relatively high boiling point. Finally, for bromium chloride, since it has a nonpolar covalent bond, it's going to have a very low boiling point. So we would predict that this would be a gas at room temperature. There are correlations between the polarity of bonds and these physical properties of compounds, and these will be looked at in more detail in Unit 10. This concludes video 5 of 5 for Unit 7, an introduction to bonding.